In this tutorial, we'll work through the node flow for doing final pixel green screen keying and compositing with the node group that Afterburner creates inside Blender. And this screen correction technique that we'll see is described in Steve Wright's book, Digital Compositing for Film and Video, and his LinkedIn course, both of which I absolutely recommend. Links are in the notes. So first of all, we're going to turn off the viewport compositor on the shading menu, and then we're going to switch to the compositing tab. Shift F10 on the upper panel to convert it to an image editor. Click on the dropdown, type V to help search, and then pick Viewer Node. Great. Over here, going to switch to the compositor, Shift F3. So then we can see our nodes layout. We have the render layers, which are the generated render layers from the Blender rendering engine. We have Afterburner, which is the node group that is created by Afterburner inside Blender. And then our output composite. And so you can scroll out the mouse wheel to shrink the size. Okay, and make sure Node Wrangler is enabled. Edit Preferences Add-ons. Type in NOD for Node Wrangler. Make sure this is checked. Node Wrangler lets us connect a viewer node to any highlighted node with Control-Shift left mouse button. So I'm going to click on the render layers node, Control-Shift left mouse button, and we get a viewer node. And this connects to this viewer node here, so we can see the output of this. And if this is blank, you may need to render a single frame with F12. And make sure to initialize the viewer node by connecting it with this shortcut while you're at the compositor top level. This is the compositing node tree top level. If you try the viewer node for the first time inside a node group, it won't initialize if you're down inside the Afterburner group when you first try it. We can walk through these node groups by clicking Control-Shift left mouse button to walk through the different output feeds. There's depth, there's the Cryptomat objects, data passes. We'll see how that works later. There's the original noisy image pass before the denoiser. All right, so we're back at the image. Let's go over and click on the Afterburner node group and dive in. Okay, now let's scale up the compositing panel a little bit so we have more room to see things. Scale down the viewer a little bit. Now we're going to highlight the camera original mode. Control-Shift left mouse button to connect the viewer to that. We'll go through this a couple times. There we go, back to image. This is just the camera original data. If you continue to Control-Shift left mouse button, it'll cycle through the different outputs as we saw before. This is just a straight image sequence input, so it doesn't have any alpha or depth information yet. Now we're going to click on the Pick Green Background Color and click on the bar here. That gives us an eyedropper. We can come up and pick on a green screen color up here, and that sets a base key. Now go ahead and Control-Shift left mouse button click on the Screen Fix Post group, and you'll see something really interesting has happened. The green screen background variations have removed. And this is a similar technique to we saw in the live keying node demonstration, but here we have a much better set of keyers that we're going to go into. And so as we can zoom in, we can see that we've actually retained a lot of the edge transparency or soft edges on this without cranking up the key, except that we now have a very, very even green screen. So how did this happen? We're going to go into this node, highlight Screen Fix Post, hit Tab. So now we're inside the Screen Fixed Post tab group. And this looks tricky, but we'll go through it step by step. First, look at the output of the source key node, Control-Shift left mouse button. And the source key is made to cut out the actor from the background. It's intentionally dialed up with a dilate setting of 9 to add onto the edges of the matte element, of the foreground element that we want to keep. And we're going to see why in a moment. Now let's look at the invert node. This takes the matte output of this and inverts it. Now we move on to Set Alpha node. This uses the inverted matte and applies it to the original green screen background. Now we have a pure green background with the cutout of the actor. Now we go to the Alpha Convert mode. That removes the premultiplication of the edges. When you have semi-transparent edges, the original green color of this is multiplied by the semi-transparent edge, so you get a darker green. If we had not done this Alpha Convert mode before we did the next mode, which is the InPaint, we'd get a darker edge transition. So you can see the difference between premultiplied and then unpremultiplied. Now we're going to go to the InPaint node. So this is where it gets cool. We are actually making a clean plate from a shot that never had one on a per frame basis. We have in-painted into the area where our actor was. Now we come to the twin keyer nodes. The important thing here is that both of them have exactly the same parameters. The top one is fed by the clean plate that we created. It's not a completely transparent key, lots of mid-ground areas, and that's important. We want that. And this bottom one is exactly the same parameters, except that now we have our actor in there. And so if you go back and forth with the viewer node, then you'll see we have a matched key, the same partially transparent artifacts on the green on both keys. Now as we move to the invert nodes connected to the matte of both, we're taking the matte and inverting it, and then we move to the divide node. Now this multiplies the matte signal of one inverted matte by 1 over the matte signal of the second inverted matte. It's dividing one by the other. What that does is it gives us a nice clean cutout of where the actor is. Now the combine color node simply takes that original float signal and it splits it into RNG and V channels that we're going to use in the next multiply node. The subtract is important because what the subtract node is doing is it's subtracting our constant green pick, our key color, from our inpainted node. So we get a result here. And the result is a map of the screen color variations between the camera original and the constant green color. This is the differences that you would see in that map. Okay, great, but we don't know where the person is. That's why we're going to go to this next multiply mode. And that punches out the actor-shaped hole in the screen correction map. And finally, we're going to add this back to the original camera image. And the result is a remarkably even green screen. And note that since the twin match keys were not really cranked up, we didn't amplify their clip black or clip white nodes. It's just a straight key, then we still have soft edge transition to a surprising degree compared to having to crank up a one-stage keyer to get rid of all the green wrinkles. So let's tab and we're going to jump back up a level. Note that the resulting green level of this is actually identical to the original green screen background key. We're going to highlight the keying node and we're going to look at its output. And we're getting decently soft transition edges here. We have some artifacts, probably due to the H.265 compression, but we'll see how that looks when we have it together in the comp. We're going to move to the alpha convert node. What that does is it pre-multiplies the edge color by the transparency level. And then we're going to the keyer live node and we highlight that and we go, wait, what happened? Why does the output suddenly look blocky? That's because we're seeing the output of the real-time keyers that don't have the sophistication of the Blender keying node. They're the simple channel key keyers. We're going to switch the keyer live to off. And now we have our nice key back. Now we move over to our familiar scale node, which sets the scale of it to the rendered size. It doesn't change here because we're in the post composite. Then finally over to our alpha over node, where we have our background of our CG rendered image from here, from our group input render image. Goes through a color corrector, which we haven't used yet, to the background of our alpha over, and the foreground is our keyed image. Alpha over is where we finally see our image come together. But her legs should be occluded by the front of the buggy, and this is where Cryptomatte comes in. So we're going to move down here to our Cryptomatte plugin and highlight that and Control-Shift left mouse button click this until you get down to the pick view. This shows all the different elements that Cryptomatte has already rendered separately. We're going to click the plus button next to the matte objects, and we're going to click on the front roll bar. Now we have that matte object in Cryptomatte. Then when we go back up to our second alpha over image, and look at the output of that. Now Cryptomatte has used that matte to have the front of the buggy occlude her legs properly. Now we're going to set the ZDepth live node to off since we want to use the Cryptomatte data for our occlusion instead of the ZDepth data. And this shows the basic path through the post-compositing node flow in the Afterburner node group. You can render the scene right now and the foreground objects will all track with the camera movement. You can move back and forth in the composite with the right or left mouse button, and the composite will shift, but the CGI image is not going to shift. In order to see that, you have to re-render the CGI image. This is why I'm really looking forward to getting all the keyer nodes in the viewport compositor, as well as getting Eevee Next working. That's going to be amazing. Eevee Next has real-time Cryptomatte. I'll send an example video in the notes. This is looking better. We still have some problems with the bottom green screen, so we'll look at resolving that in a separate tutorial. And we'll also go into matching the foreground and background black and white points and color temperature in a separate run.